Anyway, as I was saying, I apologize if I brushed through these last parts too quickly. I feel like once I spell over one, it could kind of relate afterwards. So we did that one, and finally, let's get A quadruple prime, the reflection image of A triple prime in the line y equals x. I'm sorry, negative x. So let's reflect over this line. Let's look perpendicularly at it. Here's our slope, 1. So we should go up 1, over 1, once, twice, 3 times. So let's find the reflection. Once, twice, 3 times. And it's right here at a place where we've seen before. Let's also call this A quadruple prime. And I don't have to list the coordinate locations already here. So we did that. Okay, how are A and A quadruple prime related? Well, they are the same point. And I don't have any room to write that anywhere, but, well, I'll try it right here. Same point. So we did 1, 2, 3, 4 reflections. And I don't know if they'd ask something like, what happens when you reflect 4 times, whatever. But what you do remember, and we'll talk about rotations again, but probably not in this vein, is if I do 2 reflections over axes of symmetry that intersect, then it is the same as the rotation about that fixed point which they intersect. Now in this case, when you do 2 perpendicular lines, remember when they intersect at 90 degrees? That means that the rotation is twice that amount. So if this is 90, this rotation would be 180. So I reflect over there and I reflect over here. That's equivalent to doing a 180 degree rotation about that point right there. That's a little bit extra information. But if I do 2 180 degree rotations, keep in mind that would be 360 degrees. That's why we end up back where we are. Okay, let's go backwards to number 36. Let's write an equation for the image of the given circle after a reflection in line L. In this case, our line L is at y equals x. Now we just did a graph with y equals x, so let me graph that again. Let's go straight across, y equals x, goes right through the origin, goes up 1 over 1. And so that's what we will reflect across. The best way to do this problem, in my opinion, is graph this equation first. And we've learned how to do that, but we'll do it again. After we graph it, let's pick the center point and let's reflect over this line. And then let's redraw it with the same radius, because if we're doing a reflection, remember, it's still the pre-image, which is this one, and its image are both isometry, so that means they still have the same radius. So it's okay if we just find the center point of each. In fact, we could just find the center point of the first one and reflect it, but I want to also graph it as well to give you the actual reflection. And on binder paper, you probably want to know how to graph circles. So let's go ahead and graph this. Our center of our circle, if you remember, is at hk, where h is, this is x minus h and y minus k. So our center is negative 1, 5. And the radius is the square root of 25, so that's 5. So let's go ahead and graph that. I'll go to negative 1, 5. There's my center. And the way you guys would probably draw it is, or the best way that I advise you to draw them is to just go straight down 5 units, straight up 5 units, to the right and to the left 5 units, and just put those points down. And then kind of makeshift a circle about that. So like this. So from there you would, and I'm just going to do a really quick circle like that, you would go ahead and just draw it like that. What I will do, since I have a circle tool, is I'll just go ahead and expand it from here. And it should touch all those points and we should be okay. Now if I'm asking you to reflect it across this line, some of this stuff would be kind of difficult, and what we do with polygons or any other sort of shapes is we find vertices to just pick and go across. So we could pick every single small point here and reflect it across every part of line L and do that, and then just do that again. But like I said, what might be easier for us is to just pick the center point here, reflect it across line L, find that other point, and then just do the radius of 5 again and graph it like that. After that, then we know what our center is. We already know what our radius is for our other thing to write the equation for the circle, but we have to find its new center. So that's the most important part here. So let's go and take this, and this time I'll make it blue. Keep in mind that this slope, this is y equals x, and y equals x is the same thing as y equals 1x. So the slope of this is 1, which means I go up 1 over 1. So it's perpendicular. It's opposite reciprocal. The line that's perpendicular to this slope would be -1. So you go down 1 over 1. And if you hear a cell phone, that's not even mine. That's my dad's. I have no idea where. Okay, interesting. Anyway, so let's go ahead and go down 1 over 1 and count how many times we do it. I think that's normally the easiest way to do this. Down 1 over 1. 1, 2, 3. So we will reflect across that. 1, 2, 3. And that grid isn't exactly showing up there. But there's my new center. If I reflect across this line here, there's the center of this new circle. So I could go ahead and draw the rest, but let's go ahead and write out the center first. The center is at 5, -1. And the radius should remain at 5. Okay, so we could already write the equation for the circle. Just let me go ahead and expand this. You remember how I did it last time, and let's make this one entirely blue. So I should go, let's see, 1, 2, 3, 4, 5 units out. So that looks like a pretty ideal reflection. Maybe there's some points I didn't really, maybe this isn't perfect. And somebody left a voicemail on his phone. That's beautiful. Okay, so that is... that's the reflection across this line, and if you tilt your head to the side 45 degrees to the right, then you'll see how that reflection makes sense. So let's go ahead and write a new equation for this line. It should be x minus 5, quantity squared, plus y plus 1, quantity squared, equals 25. And that should be your final answer. All right, so that's the end of 12.1. Let's go on to 12.2 and number 35 here on 12.2. This one would be a little more like vectors, and let me actually make vectors this time. If you remember vectors, when you add vectors and get a resultant vector, that's the kind of thing we're doing. Okay, Nakisha, I'm going to say that's her name, and her parents are visiting colleges. They leave their home in Enid, Oklahoma. So the first thing I want to do is locate Enid, Oklahoma, and I'll put that on my origin. Call it Enid. And it might not matter where you put it, but the point is where everything else will be in relation to it. So I also put north, south, east, and west because they'll be doing directions like that. So left their home in Enid, Oklahoma, and so they leave it and they drive to Tulsa, which is 107 miles east and 18 miles south of Enid. Now what I am going to draw are two different vectors, and they are not the route that they drove, but this ends up being two vectors that are added together to make a resultant vector. So first they drove 107 miles. Whoops. First they drove. Well, I'm not really sure what's going on, but first they drove 107 miles east. Oh, there must be something on my screen. 1 second here. Something might get messed up. I'm just wiping it around. All right. First they drove 107 miles east. 107. And then they went 18 miles south. I mean, that's not what they first and second did, but this is the location of Tulsa, which is that far away from Enid. Now, technically, this would be my resultant vector. I would draw it out this way, and I'd say this is a direct path from one to the other. Let's get that a little better. Well, whoever decided to call. Okay. So here's Tulsa, and we don't have to solve for this part right here. This is just showing a resultant vector and saying, if you remember anything about vectors, this is the direction from one point to the other. From Tulsa, they go to Norman, which is 83 miles west and 63 miles south of Tulsa. So if I start from this point Tulsa here, I'm going to